Good evening, everyone. I am Cadet L. Brian Digger, and I'm going to plot the Eplan 1D. So we have the tools here to plot the right things, the right instrument. So we have the um, compass divider, contractor, and pencil. Also, we have a use of for the listing. We have a ball pen. This is not necessary. At first, it is very important to know the description of our scenario. So, this is the scenario. At 1330, the vessel is at the vicinity of the west part of Panay Island on course 200 degrees. At 1330, the vessel is at the vicinity of the west part of Panay Island on a course of 200 degrees through times 10 knots with a failing tide with a tidal stream speed is 0.6 knot. The officer of the watch or means OOW observe Pusho Lighthouse. It bears 330 degrees with a distance of 6 nautical miles. Plot the ship estimated position. So estimated position at the 400 hours. And we have the true bearing. If we have the bearing of 200 degrees and also the 330 degrees relative. Right now, we have the true bearing of the Pushu Lighthouse. So the bearing of the Pushu Lighthouse is at 200 degrees true. So right now, we have a true bearing of 200 degrees and a relative of 330 degrees. So we're going to add 200 plus 330. So we have 530 degrees. So it is not applicable because we have only a 360 degrees of bearing. So we are going to minus 360 degrees. So we got 170 degrees true bearing. So right now we're headed to our chart. The first thing to do is to find the true bearing of 130 degrees course. So here we are, 170. So we are going to locate the 170 degrees bearing, and so that we can slide it to the perfect location. So Pusho Lighthouse, I'm going to put an mark in order for us to have a perfect bearing position. Next, so the distance of the Pusho Lighthouse is we have 6.6 nautical miles. So we're going to count. We have 45 minutes. We have 45 degrees in 11 minutes. So 1, 2, 3, 4, 5, 6. So I'm going to put a mark to have the perfect location of perfect nautical miles. 6 minutes. So I'm going to put a fixed position on the true bearing we have right here. Oops. And we are going to put a circle to have a fixed position. So next we are going to locate our next bearing, which is the 200 degrees true. So 200 degrees true, 200 degrees true, and I'm going to put a mark. I'm going to slide it and go to the fixed position so that we can have the total exact amount of total position. So we have the line of position, and we have here the fixed position. Don't forget to write the bearing or the fixed position of the line of position. So we have 200 degrees through bearing. It's about 10 knots. So we have the fixed position here. So 1300 hours. So we are going to find the distance and the nautical miles. So we have in the scenario we have 200 degrees through bearing. So we have 10 knots. So half of the 10 knots is we have 5. So we are going to count 5. We have 11 minutes, 11 degrees and 45 minutes. So 1, 2, 3, 1, 2, 3, 4, 5. So we have 5 distance. So we're going to put here to find the exact position. So we're going to put a box here. So we call this DR of 1400s. Okay. So we are going to measure the current of the water. As you can see, this is you're going to slide your contactor. So I'm going to slide my materials in the exact position of my second bearing. So we have right here, this is my position. So going to put an arrow. Okay. We have the tidal stream of 0.6 nautical miles. So we're going to, this is 11 minutes and 11 degrees and 45 minutes. So we're going to count. By the way, if you can see, this is a 2, 4, 6, 2, 4, 6, 8, 10. This is a by 2. So 1, this is a 5, 10. You can see 2, 4, 6, 8, 10. So this is by 10. So we are going to find the stream tidal of 0.6. Or we have 2, 4, 6. So we have right here. So I'm going to put an 1, 2, 3, 2, 4, 6, 2, 4, 6. Right now, we're headed to our fixed position of the tidal stream. So we have right here. Two, 4, 6. Okay. Yeah. So we have right now the perfect posture lighthouse that we have 170 degrees bearing. So as you can see, is the line. And also we have the fixed position of the 200 degrees through bearing as here. And we have the 10 knots. So half of the 10 knots we have 5 knots. So the DR is 1400 hours. We have the fixed position of 1300 hours. So as you can see, we're going to find the longitude. So we're going to find the longitude. So we're going to slide here. So we have 1 to 1. 121 degrees and 9 minutes. So that is the fixed position and true bearing of the 1D, Eplan 1D. Thank you.